here we have started with a model for our solar panel. Here are the dimension for them. It's 5.5 centimeter in center, 110 for each corner. And we have done the boss extrude for 2.5 centimeter thickness. You can see here it's 2.5 centimeter thickness. Okay, now we'll start with the heat sink. We have done the model, the same dimension, 110 by 110, and we took the thickness of 8 centimeters, which is a good size for the heat sink. Now we'll do the cut extrude for the fins. They are square shapes. We did this linear pattern. Now we'll do the extrude, cut extrude. We will take it for 6 centimeters or 7 centimeters. So it has a base just before the 8 centimeters. And we will select the contour shape of the cut extrude, these fins. Now we have this fin feature. Now we have we can also change, since there is
so I want you to do some
small amount of fins. We can also
and you can do you can do it for the cooling tower.
Can make them more
For the cooling
by
tower, at least
reducing the space here.
You can make at least a structure.
This is, let's make it 0.5. This will give more fins, and we will change the linear pattern also.
Plastic pieces, I don't think maybe taller than this.
Maybe we will do no, the feature. Where is the feature? To this feature.
You know the cooling tower that is used for power plants.
Okay, this linear button.
What is this pipe? It can be moved. So it's available.
Yes.
It is of good shape. This heat sink. Okay, we'll save this part. Heat sink. Okay, now we will do assembly. Open a new box. Assembly for the thermal analysis, and we will choose the heat sink with the panel. This is the heat sink. This is the panel. Okay. We will make them right now. This surface, this surface, and this. This surface with this surface, okay, and this surface with this surface, okay, and this surface with this surface. That's it. And we'll save this assembly 1. Okay. Now, as for the thermal analysis, we have the simulation. We start a new study. Okay, we want a thermal analysis study. We can select it. Then we should exclude, first thing, we should exclude the heat exchanger or the heat sink from the analysis. We want to see the effect of the heat power on the solar panel only. So we select the power and heat sink. We exclude from analysis like this. Now we apply the thermal load. We have different types here. We have heat power and radiation for the solar panel. We have a heat power of on the exposed surface 5 watt.
Okay.
And select OK. This is on this side. We can also add radiation power. We need here the ambient temperature. We will give them. We assumed in the calculation 42 Celsius degree, and Boltzmann constant, or the emissivity, of 5.67. Oh, 5.67. 5.67 e to power 1/6. Okay, and select also this power, these surfaces. Radiation will be absorbed by these ones, and select OK. Now we can create a mesh to see the distribution of the heat on the surface. We can create it, find, of course, find is better. This is calculating the mesh. Okay, it's taking a long time. Okay, so did the mesh like this, and now we can run the study and see the effect from here. Run this study. Click material. Oh, we have to define the material first, right? Panel should apply a material of silicon. Now can run the study. It's solving. Now what we have done is we have made a study, thermal analysis study, without the effect of the heat sink, only on the solar panel. After this we will do it including the heat sink, like you can see here, it's not included.
Because we are not covering it in a box.
ما في باص.
بدك تقصر عليه. قصر جدي عليك.
نقصه يعني.
Ambient temperature you can assume, like say.
والله شكله مطول. وقف.
هذا بعد ما دخلت أنا الكونفكشن.
قفل يعني.
دقيقة دخل الكونفكشن لازم والله. Should have added convection to the surface, the contact surface. Select all exposed traces and it will select automatically. We will add a convection coefficient of 23 for air, watt per meter square Kelvin, and the ambient temperature is 315 Kelvin, which is equivalent to 42 degrees. Okay, and we will add it. Now we can create the mesh again. Fine. And run the study.
To address the shading factor, just to calculate the distance between the pillars. We will go with that.
We will see after the study is finished from running.
Keeping the width constant.
Now after the study has been run, we have these results, as you can see, of the temperature variations. you can edit them, and you can also you can add the maximum and minimum point, and you can show the minimum annihilation or maximum annihilation like here on the service. So here we have the maximum temperature of 53 degrees Celsius, 0.34, and here on the far left corner we have the minimum. And that's it for the analysis without the heatsink. Now we will add the heatsink. We will duplicate this thermal study
لأنه يقول لازم تخلصون عشان يبدون.
and in here we will add the part,
بس ما حتى رحت هناك بس.
include in the analysis.
الخلق
The same analysis, but we will change the convection because there are more surfaces right now. Now we will edit the definition and also select all exposed surfaces. This is the convection. The same convection coefficient and ambient temperature. Now we'll create a new mesh and one. It's creating the new mesh with the extrude, the heatsink, and it will show the result in a few minutes.